Hello everyone, hope everyone is doing great. In this uh, lecture or in this episode, we're gonna discuss about a network infrastructure. It's when you ask someone as a network infrastructure, it's a kind of huge topic because it does require a very sophisticated design or very complicated design. But in most case scenarios, even though if you have internet at home or let's say in a small office in any places, the design is already there, but there is a proper word and there's a proper standard that we have to follow and following to these standards in order to make sure that when we design our network and we have to make sure that there is it really follow the standard of the international standard organization. Generally, there's two types of the network infrastructure design. The first one is on premises, and the second one is on the cloud. So there's the two types of the network design, as I mentioned in here. I need you guys' attention. It's very important. As I mentioned, we have, let me change the color. We have a tier 3 and we have a tier 2. So tier 3 is Cisco inheritance design. Guys, I need you guys' attention in here. It is a Cisco inheritance design. Probably the question is, are we still using this design? The answer is, of course, we are using this design in the most part. So before we move on about discussing about the inheritance design, allow me to draw something in here to clean your mind. Let's say, just give me 1 second. Let's say we have an office. Let's say this is a big building. This is a building, and in this building, let's say these are three floors. I need you guys' attention. These 3 floors are connecting with one another, and all network equipment, let's say routers, switch, firewall, even you have a load balancers, or whether you're using wireless controller or lightweight wireless controller, it doesn't matter, but it is in this building. So if you look at this diagram, what we learn in here is that there is no cloud involved in this scenario. So the question is, why not our internet connect from here to the cloud, which is ISP, Internet Service Provider. That makes sense. So that is an internet service provider, but we don't have any server. Let's say our servers are connected here, our firewalls are connected here, our let's say our switches are connected here, and another switches are connected here. Our let's say load balancer is connected here, and our proxy server is connected here. So these are connected in the same building. So if it is connected in the same building, what we call this one? We call this one as on premises. Just give me 1 second. Let me write it down in here. This is called on premises. Remember that this design is called on premises. This is called on premises. So this design is called on premises. The question is why? The answer is because if you look at in here, the building is combination of all the network equipment we have. All right. In case if you want to make any changes to all these equipment, what we're gonna do, we need what? We need a developer, we need a network engineer, we need a computer guy to log into these devices and make a changes. Let's say one console, another console, in order to make changes and configure. So this is called on-premises. Keep in your mind, this is on-premises. And this is also called Cisco Inheritance Design, or we can say Tier 3. What is Tier 3? And Tier 3, we have, just let me write it down, the steps in here. We have a core, layer. We have distribution, this distribution layer, and we have access layer. We have access, access layer. I want to explain these all one by one, but I need you guys' attention. I'm talking about the Tier 3. This is Cisco Inheritance Design, and this is how we're supposed to design as well. Let me wipe this all configure, this all design, and I want to run it once again. Let's assume that we have a server room and we have a network rack. We have a network rack. This is our network rack. When you go to any server room, any data center, any places, you can see that there are 100 and 1,000 of rack. On the top, what we're gonna do is we have to place our core devices. And the bottom, we have to place our distribution devices. This is very straight, I like it. And the last one is access. The last one is access layer. The blue color is access layer, and the yellow color is, let's say, distribution layer, and the top one is core layer. The top one is core layer. This is how you're supposed to design. I need you guys' attention. This is how you supposed to design. So this is my most of the time we can say L3 switch. Layer 3 switches in here. We are using L3 switches, and the distribution layers nowadays, most of the people use L3 switches because it's a bit challenging to find L2 with that functionalities, or L3 switches, layer 3 switches or layer 2 switches. And the last one, we are using the L2 switches. So the question is, what makes the difference between L2, L3? It is very simple. If you guys are familiar about the OSI model, we have application layer, presentation layer, session layer, transportation layer, network layer, and data link layer, and the last is physical layer. It is the same thing. Let's say L2 layers is the types of switches that let's say L2 switches are types of switch which is based on MAC address. Based on what? Based on MAC address. This is called the based on MAC address. Guys, if you remember OSI model, we have 7 layers of OSI model. So the last 3 is very important. We have let's say we have a physical layer, we have a data link layer. If you remember, guys, we have a data link layers, and we have a network layer. So I need you guys' attention in here because I want to explain a little bit brief. The physical layer is what? The physical layer is, let's say, the network cable. The physical layer is a network cable. Let's say if I connect this device to this device, this device to this device, this is a physical layer. Let's say wireless antenna, any types of cable that you're using, the connectors and ports, all are physical layer. Now this is called layer 1, this is called layer 2, and this is called layer 3. So layer 2 is based on MAC address. So that's why my suggestion is to try to make sure and get familiar with the OSI model. It's very important. Search about OSI model. It's gonna be very clear for you as well. So these layer 2 switches are based on MAC address, means we are we are dealing with the MAC address. So what we are, which in where we are using these kind of switches, sorry, this is layer 2 switches. Let me wipe it. It should be layer 2 switch. So my mistake is L2, layer 2 switches. So this is gonna be clear for you as well during of interview what makes difference between L2 switch and L3 switches. So now we have another switch which is called L3. Let me grab the blue color in here, and this is called the L3 switches. What is this L3 switch? Or this is the third layers of OSI model, which is based on IP address. It is based on IP address. So nowadays these kind of switches are very smart. It provides routing as well. It does provide NATing as well. It is probably in some of the design, if you go in a data center or any server room, any places, you would see that there is no router. There's no Cisco router, D-Link router, Fortinet router, Palo Alto router, or any other company router as well, because they're using a switch, or maybe they're using firewall. Don't get confused, because right now we are talking about the network infrastructure. So let's say in the left side, this is how I design my network rack. There's two types of rack. One is a server rack and another is a network rack. From the experience standpoint, remember that. All right. So it looks for me that I think it looks for me the concept is slightly clear for you guys, that what are these all about. Okay, so let's talk about a little bit about the core layer. It is, we can say, service as a backbone, or we can say it serves as a backbone of the network, and it's a interconnected distribution switches. These devices should be high speed and able to forward packet as quick as possible. Which devices? The L3 devices. These devices should be very fast and capable of forwarding packets very fast. And yeah, that's layer 3 switch. That's why. So let's talk about a distribution layer. So what is the distribution layer? Distribution switches, or we can say aggregate traffic from the access layer switch before it's transferred to the core layer. Routing, filtering, and QoS feature as usually managed here. Remember that if you want to configure routing, if you want to configure any types of filtering, or if you want to do QoS, quality of service. So the purpose of quality of service in here is that we are trying to configure. Just give me 1 second in here. Let's say we're talking about the distribution switch. It's L2 or L3. In here, one port is connected to the laptop, and one port is connected to the voice over IP. Voice over IP. Remember that voice over IP. If someone is using the phone, let's say this, let's say handset. If this guy is using voice over IP connected this one, first this port required very reliable internet, and the second, it required very stable connection. The third, it consume a lot of internet. This is not the data. This is not a Word. This is not Excel. This is not just email exchange. This is voice. It's heavier. Let's say if we can talk about the video is heavier than voice, and then we have a data. Data is like Word, Excel, PowerPoint, or PDF, or any types of data that you name it. So in order to figure out and provide a proper and stable connection, we have to configure QoS in this place, and we can limit the bandwidth for this one. Like, hey, when you're using voice over IP, I don't want you to use all internet. I don't want these clients are suffering while you guys are using voice over IP. There are a lot of technologies nowadays. Probably most of you know. If you doesn't know, that's fine. We can configure a specific VLAN for voice, and then we can QS those kind of things. And we do have a specific range of IP address. We're gonna discuss probably about the range of IP addressing and so on, maybe in the next video. But I need you guys' attention in here. So we're using QS in here. Routing is like, okay, let's say I have a 2-core switch for redundancy link. Let's say if one L3 switches goes off, it should connect to the second switch. So what I'm going to do for this kind of scenario is very interesting, and I need you guys' attention. I would say whatever voice requests come here, it should go to the first L3 switch, and whatever data requests come, it should go to L3, but the second core switch. So this is how you can, let's say this is how you can do the QS. This is how you can route the data, and this is how you can filter. The another question is, how am I supposed to filter? One of the another important topic, let me share with all of you, is very important as well in here, is that let me a little move it up, and here is the diagram. I didn't see this screen, and I thought that's already it's not. I thought it's fetch, but it's not. But anyway, all right. So we were discussing about the filtering. Okay, for the filtering, we have types of technology, which is called switch port analyzer. I need you guys' attention. It's very important. Probably you find this kind of topic when you're getting your CCIE or CCNP. Okay, so what I'm going to do, I would say that this client doesn't seem very good client. So my attention in here is to I would say, let me track whatever is going on in here and send the mirror of this one to one of my let's say if you're familiar about the Wireshark, send these all notification to my Wireshark, and I want to see what this guy is doing. It's a traffic sniffing, but for good purpose. This is called Wireshark. This is called the Wireshark, and search about that. That's a good tool. It's free, and you can install it and install. And this is the feature that comes with the Cisco switch port analyzer. This is how you can filter the data. So the reason that we have these kind of things based on the Cisco inheritance design, or let's say tier 3, is that we have to make sure that we have full control of our network. So let's talk about the last one, the access layer. All right. The access layer is most of the time based on what I designed the most. Is that just give me 1 second. Yeah, what I designed the most. This is L2, and we can see a layer 2 switches. We are connecting the all switches, whether it is in the first floor, whether it is in third floor, whether it is in the fifth floor, or whoever is on that specific floor. Let's say this is the first floor, and this my switches are connected in here. So I'm connected to the L2 switches. So I'm connected to L2 switches. So let's see what is L2 switch and why we need to use L2 switches. Access layer. We're gonna discuss about the last layer in here. I need you guys' attention. I'm talking about this layer. Access switches connect end devices to the network. It could be anything from your computer, IP phone, printer, or camera, or anything that you name it. So the access layer switch is designed for connecting our devices. What? The access layer switch is designed to connect our devices to the switches, whether it's a laptop, tower top, palm top, smartphones, wireless access point, anything that you want. In order to keep let's say distribution layer and core layer separated from the access layer switch, because if you remember, we discussed that the core layer is our backbone. So in a Cisco inheritance design, let me wipe this one. You want to take a picture of it? Go ahead and take a picture of it, because I'm going to wipe it. All right, here's what I wipe. But this is how Cisco inheritance design is in general. This is how Cisco inheritance designs are in general. We have the last one, the access layer, and the middle we have a distribution layer, and the top one we have a core layer. So the core layer is that our backbone. Let's say this is my core switch. I have a 2 core switch. I didn't want to cross the screen. Yes, I'm in the screen. So this is my, let's say this is my distribution switches, and these 2 are my access layer switches. So in order to connect, we can connect one in here for the redundancy. I have a connection here as well, and meanwhile I have a connection here, I have a connection here, I have a connection here to here, and this is how we can say some mesh topology as well. If any ports of this one, we are using spanning tree protocol. So probably spanning tree protocol is a technology with the Cisco, which is called spans. Spanning tree protocol. This is called the spanning tree protocol. Spanning tree protocol is prevent the loop and find the base path and find the base path and find a base route for our, let's say, for our client. Let's say if I want to send a message from this computer, it goes from, let's say, from this switch to this switch to this switch to internet, because that's a base path I found with the help of the spanning tree protocols. That's a protocol, and I can see the types of L2 protocols as well. It's based on MAC address. Okay, this was a brief information about the tier 3, let's say, network infrastructure, and I'm sure it's not too much complicated, so I thought I'd put it in the nutshell. So this is the network infrastructure for tier 3. Let's talk about the tier 2, that is the data center network design and how we design in the data center. I hope this was a benefit for you, and I would like to thanks for viewing. In this video, in the next video, we're gonna discuss about the tier 3 with more details.